Welcome to 5.4 Solving Trigonometric Equations. Let's look at the first question. Cos of x plus root 3 all over 2 equals 0. The first step is to try to get cos of x alone. To do so, we need to move the root 3 over 2 to the right side. So cos of x equals negative root 3 all over 2. Let's look at the cast rule to figure out when cos is negative. Cos is negative in quadrants 2 and quadrants 3. The adjacent side is negative root 3, and the hypotenuse is 2. If we take a look at our special triangle, we can easily find out which angle we're looking at right here. On the inside, we will have pi over 6. So let's look at quadrant number 2 first. In quadrant 2, x equals pi minus pi over 6, because we're finding out what it is from here to here. So x equals 6 pi over 6 minus pi over 6, because we're finding a common denominator. So x equals 5 pi over 6. That's one solution. Quadrant number 3. We have x equals pi plus pi over 6. X equals 6 pi over 6 plus pi over 6 with a common denominator. So x equals 7 pi over 6. There's another solution for us. So therefore, our solutions are 5 pi over 6 and 7 pi over 6. Let's look at a more difficult question now. Sine 2x equals 1 over 2. In the intervals, x is an element of 0 to 2 pi. So first, let's find out when sine is positive. Using the cast rule, we know that sine is positive in quadrants 1 and quadrants 2. The opposite side is 1, the hypotenuse is 2, opposite side is 1, hypotenuse is 2. Using our special triangle once again, this is going to be pi over 6 and pi over 6. So in quadrant number 1, 2x, because we're solving for 2x equals pi over 6. We need to try to get x alone. To do so, we need to divide the left side by 2, multiply the right side by 2. So x equals pi over 6 times 2 over 1. So x equals 2 pi all over 6, which is equal to pi over 3. Here's one solution. Since it's 2x, we're going around twice, so it's going to be, you need to find another solution, so it's going to be x equals pi plus pi over 3. So x equals 3 pi over 3 because we're finding a common denominator. X equals 4 pi over 3. There's our second solution. Let's take a look at quadrant number 2. 2x equals pi minus pi over 6 because we're looking at it from here to here, so you need to subtract the pi over 6. I need to solve for the right side first. 2x equals 6 pi all over 6 minus pi over 6. 2x equals 5 pi over 6. Divide this by 2, multiply this by 2. X equals 10 pi all over 6, which is equal to 5 pi over 3. There's another solution for us. And we need to add pi to this as well, so x equals pi plus 5 pi over 3, which means x equals 3 pi all over 3 plus 5 pi over 3, because we're finding a common denominator, so x equals 8 pi over 3. There's our fourth solution. Therefore, x is an element of pi over 3, 4 pi over 3, 5 pi over 3, and 8 pi over 3. And those are our solutions. Now let's look at a more challenging question. If we have cos squared x minus 2 cos x minus 3 equals 0. In the interval, x is an element of 0 to 2 pi once again. So to do so, first we need to find out what this side is equal to. This is a quadratic equation, so we can factor the first side. We need to find a product of negative 3 and a sum of negative 2. So we have cos of x plus 1. Cos of x minus 3 equals 0. Solve for each of these individually. cos of x plus 1 equals 0. Get cos alone. Cos of x equals negative 1. Cos of x is negative 1 when x is equal to pi, and we can see this when we graph the base function cos of x. This is 1, negative 1. And it only comes down to its minimum when x is equal to pi, so there's one solution. We just solve this side. Cos x minus 3 equals 0. Cos x equals 3. This has no solutions. This has no solutions because the base function of cos does not exceed 1 and does not go below negative 1. So therefore, this is no solutions, and our answer is x equals pi. Thank you for watching 5.4.